Hi. So I'm Soos, and I'm going to be talking about what IT security professionals can learn from safety literature. I personally have been doing IT security for about 20-something years, and nowadays I work as a researcher and also in the Ethereum Foundation. So what this talk is going to be about, let me try to make this slide a little bigger so I can see it myself as well. So basically, safety engineering, I think, has a lot to teach us IT security professionals. And I hope by highlighting some of the commonalities between what safety science has to offer us, we can become sort of better IT security professionals. And this talk is not by any means comprehensive. The IT safety literature is immense, and clearly I cannot squeeze it down into a 30-minute talk. But this is to pique your interest, and maybe you can, look. I'll have plenty of references at the end, and you can try to have a look at what you're, interested in, and try to bring some of these ideas into your practice as an IT security engineer. I would also like to note that clearly, obviously, security is not the same as safety, right? When you're in a mine, there's nobody trying to release methane gas on purpose and lighting it on fire. That's not what's happening in a mine. But at the same time, when there are miners who will turn off the methane gas detectors because it annoys the hell out of them, there's going to be management who set production targets that cannot possibly be met, given the tick box exercise of security, of safety that they mandate, without any form of inventive idea of trying to meet those safety goals that those tick boxes are supposed to meet. And there's going to be people who've been doing this for a while and feel uncomfortable and leave the mine and just stop working because they don't feel comfortable doing this. And in some sense, I think these IT security professionals have all been in this mine, right? We have all seen all these issues in our daily work and feel sort of, is there something that we can do, that we can learn from these accidents and issues that have happened in safety. So I also want to talk a little bit about what this is not about. This talk is not going to be about some kind of prescriptive thing that you're supposed to do as a mandatory thing. This is a bunch of ideas that other people have thought about and put quite a lot of effort into, and for you to sort of just think about them and see how you can incorporate some of this into your daily practice. You need to find your own way. There's no way that is prescribed to do this. And I think you have been, as IT security professionals, you sort of know this inherently when you go to a new company that you work at or a new consultancy gig that you got. You have to sort of understand their context and where they're coming from and incorporate your knowledge and your know-how into their processes so you can help them the best you can. But I think it's important to also realize that a lot of time, effort, and money has gone into safety science. And plenty of people, unfortunately, died that eventually resulted in massive amounts of work done to try to understand why and how can we prevent this from happening again, right? So I just want to start with something called down and in versus up and out. And I'm going to start with something, a scenario that I think we're sort of familiar with, or let's hope we can all try to be familiar with. Let's say there's an attacker, they got into your company with some kind of phishing attack, and they pivoted around in your infrastructure. And this was noticed because somebody was just looking around their AWS account, let's say, and they saw something suspicious that didn't feel right, and then they notified the people they knew best, which was the administrative team, like, hey, something is off, is this your account? And the administrative team was like, oh, wait a second, this is definitely not okay, and they shut down this attacker at their trails. And this, that there's no real leak of information, I think, that actually happened that you would need to report. Okay, so this is a scenario that I think we can all sort of agree can happen in a large enterprise. And let's look at sort of the classic interpretation that you would have within an enterprise. Well, user clicked the bad email, right? So therefore, the user needs to be trained. I think we've all heard this explanation. We lack preventative measures against pivoting, right? Let's add the preventative measures that we lacked, so the attacker couldn't pivot around our infrastructure. We lack detective measures because clearly the SOC didn't see this happening. Somebody else did. So let's add these detective measures that were somehow missing because when the system was conceived, security wasn't even asked whether they have any requirements that would need to be part of the requirements analysis that they did for the system when they built it, right? And the sysadmin team had manually fixed the stuff, right? So they had to go in and manually fix it. There was clearly no reactive measures, so we were lacking reactive controls. So this is kind of a classical explanation that you'd see in almost all IT security places that I worked at. They go through this kind of interpretation and that's what happened. This is the thing. Right, and this is what, in safety literature, this would be called down and in. And I'll talk a little bit about what I mean by up and out. So there are two ends of this sort of instrument. There's the sharp end, the people who are actually writing the code, the people who are the systems that are at the end of what happened, right? So they're the user who clicked the email, I think that's clearly a sharp end. There is the sysadmin team that reacted, right? And there is the system that was compromised. These are all very close to the action that happened, right? We all understand that these are intimately close to what actually took place in this scenario that I just described. But there's also the blunt end, and I think very often we forget the blunt end and forget to ask questions about it. And if you actually think about it, if you have a look at some of the safety literature, they'll talk about the blunt end basically non-stop. And if you still start talking about the sharp end, they just look at you like, have you lost your mind? Like, are you kind of interested in losing your mind here? Because it will be not interesting to them. Because they understand that if you fix what's on the right-hand side, the stuff on the left will not only be fixed, but all the other issues will also be fixed. So what is on the blunt end? Well, this is what they call the distal cause, so the things that are further away from the direct thing that actually happened. And this is the lack of priority for the detective measures, right? Because there's 50 people, let's say, in your organization. This is a large organization. What the hell were you doing? You were clearly doing something else, right? Because they weren't just sitting at their desk and twiddling their thumbs. So they must have done something else. And they must know that detective measures are important, right? So what else was important? And more importantly, the other thing was more important, that who made the decision and why was that decision made? And you shouldn't try to blame this person who made this decision, but we should all sit down together and decide how are we making decisions about priorities. Because you haven't actually thought about the way that you make that decision if you arrive and correctly in a way, because you clearly arrived at something that wasn't what you really wanted, right? So maybe the people who make these kind of decisions need to do that differently. And it could be various other ways, but maybe there's something to be done there. Now, let's say that there's this system, right, that was built without the involvement of IT security. They built this system, and they somehow forgot to talk to IT security about the requirement, during the requirements analysis phase. So the preventative measures were never included. Why? Right? Why did this happen? Why was IT security never informed? And I don't mean going there with a baton and hitting their heads. You should be actually curious of why we were completely unaware that we're there, that we exist. Actually, do they know we exist? Do they know our emails? Do they know that for every new system that they're building that is anything major, they probably should be including these kind of things? And if they don't, then that maybe says something about your communication methods towards the enterprise itself, because you're part of this enterprise. You haven't communicated that you exist. Let's see that there. Well, anyway, let's hope it comes back. That's good. Okay, so we can also talk the same way about phishing email, right? We can say that this phishing email likely was observed by other employees. Why didn't they notify us? Do we have actually a good rapport with people? Are they afraid to send us this email? I have seen organizations that people are actually afraid to report security incidents because then the security personnel come down on them, and then it's a huge pain for them, and they're like, oh, let's just keep it internal, right? Let's not talk to the IT security people. But if that's happening, then maybe your attitude towards what's happening around is the problem, and you can try to fix that. right? And I think you all understand. If we get that thing right, this thing on the per user clicking the wrong email is going to be almost a secondary question, right? Of course, it's interesting. We do want to understand it. But the thing is, you start here and you end up there. The problem is that the people start here and they end here. Okay. So next thing is, who do you blame? And of course, if you blame the thing that's at the sharp end, what will you get? Well, you will get trainings, right? You will get some detective systems, and you will get some preventative measures. And that's more or less what probably happens right now in most enterprises, right? So notice that it's always easy to blame the things at the sharp end because they're obviously connected to what just happened, right? They were obviously there, like the person obviously clicked the email, right? But it's not that obvious to think about, okay, but who else got this email and why didn't they actually notify us? That's a more complicated question to both ask and to answer. Okay, so instead of, what other things can you do? Well, you can, as I just explained, right, you can try to understand why security was not involved, or you can try to say, well, there was something really interesting happened here, actually, that we sort of forgot halfway through this scenario discussion, because somebody actually did something that they clearly were not, like that was not their job role, that was not their part of their policy or guideline or the ways of working or whatever. They noticed something that was not right. So there was some kind of positive slack in the system. There was some kind of positive control in the system that actually helped you get out of this sticky situation, right? And if you think about it, the sysadmin team, that's not their role, it's not the thing that they normally do, but they actually did do the right thing, right? So again, there was some kind of positive slack in the system that worked in your favor to get rid of this problem. And actually, if you have a look at all the things on the left-hand side, it's all the negative slack. It's all the things that, like, you looked at the thing and you found a hole. You found something that was missing. That's called the negative slack. You found something that was just not there, even though you really hoped it was gonna be there, right? But on the right-hand side, if you have a look at the things that actually did go right, it was things that were positive slack in the system. Things that were, you never trained the sysadmin team to do this. You never asked people, you never trained this person to look around for things that didn't go right. That wasn't the kind of stuff that they were expecting, yet they did the right thing. It's not, this kind of scenario is something that is actually in my mind, but it's more an amalgam of other things I have seen and I have read about. And it's quite classical that the things that do go right are actually the positive slack in your system, and they are the ones that will save your ass. And not the holes that you've been plugging all day long. Okay, so this is this kind of positive slack and the negative slack in the system, right? So when you have this, you see the things that are like missing, the holes that you want to plug on the left-hand side, right? This kind of what is missing and what are the things that I need to fix because it's broken, and all you're looking at are the things that are broken. And instead of looking at the things that did go right and actually are kind of interesting and you could do better. For example, you can try to do wargaming with the sysadmin team. Like clearly they're quite capable of doing the thing that you wanted them to do. So maybe you can train them to do it better. Maybe they can be part of the team, and we together can try to make this enterprise more secure. And so that's, I already explained about this person who noticed something unusual. Maybe you can try to recruit this person into the IT security team. Maybe they could be the IT security champion within that department and help that department be part of your, project the knowledge and know-how that you have into that department so that you can make sure that next time they build something, they won't be missing the preventative measures. Okay, so we're just gonna jump a little bit topics here. I think it's also important to recognize that security is sort of, it can be looked at least, as a hierarchical control system. Where, like a normal control system, you have this kind of control loop. You want to heat, 100 liters of water, and you put some heating into it, and then you measure the temperature, and eventually it gets too hot, and you turn off the heating, and then, it gets too cold, and then you turn on the heating again, right? So this is a typical control loop that you would have when you try to heat up water. Now, IT security does have a certain thing, like you can look at IT security from this perspective and say, well, there's, of course, the public who's unhappy about certain things, and they're going to pressure the lawmakers to make laws. So the lawmakers are going to make laws, and then they're going to tell the laws are going to be made, and the regulators are going to try to enforce these laws. And then the regulator is going to try to enforce these laws on the company, and the company is then going to try to enforce that through their managerial control, right? And then the managerial control is eventually trying to push this control through often you, the IT security professional, who will write policies and guidelines and ways of working and all that sort of stuff. And eventually, the person who's writing the code at the sharp end will try to keep in mind that the things that they need to write, need to meet all those obligations that are up in the hierarchy. Right? And then there's this reporting line that goes all the way back up, right? Where we're going to monitor the people who are writing the code, and we're going to write some risk reports and compliance reports, and then the management will be happy about it, and then the company reports that back to the regulators, and the regulator is going to report back to the government about how we managed to implement the laws that we have that have been set by the public, right? This is this kind of loop, right? The question is not whether this exists. I mean, I think you all understand that this exists, and if you ever had the chance to talk with the regulator, you know that this exists. I think it's something to think about of where you are on this chart, really. Like, where are you within this? Because you are somewhere in this control loop, and it might be an interesting thing to think about where you are and where you want to be. And often a person who is, let's say, an IT security professional will be in multiple places within this loop. You're also, of course, part of the public, so you can influence public opinion. And some people in C-base, you might say, have more say in pushing public opinion in some direction than others. But you're also writing code, and you're also frontline personnel in some ways, right? You're also doing things that get executed, and it could potentially be even online and affect the overall security of the system directly. And of course, you have indirect control in other ways, right? You write risk reports, and that get propagated up, and then eventually might even reach the regulator. And then, of course, the regulator through government. So it's just interesting to think about and something to keep in mind that this is one way of looking at security as a control loop. Okay, so I just want to talk about something that I think is quite interesting, and you might see some similarities. So how do frontline people, frontline work gets adapted in the centralized mode of safety? So centralized mode of safety is something that I'm sure you have seen. Is basically the centralized mode of security. We all write policies and guidelines and stuff, and we just beat people on the head so that they would meet those guidelines, right? So what happens? Well, there's going to be these guidelines and plans and notes and requirements that these people should be doing as part of their work, right? This is the plan that we set forth for these people to do. And then what happens is that these people actually need to get some work done. And clearly the policies and the guidelines and whatever were never consulted with them. So they need to smooth over some of the sort of rough edges. They will try to do what's called fluency. Within the safety literature, this is called fluency, which is an activity that smooths over these kind of contradictions that they're supposed to do, but they're supposed to like meet these policy requirements, but clearly, they also have some work to do, and the work to do doesn't quite seem to fit with what is going to, be set forth in the policy. So they try to smooth it over. And if you look at it from the outside, it sort of looks smooth. Like they seem to have figured it out. And what happens is that when they keep on sort of smoothing over these kind of contradictory requirements, they're going to start discounting the kind of stuff that they smoothed over. What they'll say is like, yes, we kind of know that it's not exactly true, according to policy, but it's kind of not too far away. And this kind of discounting will bubble up to management as well, and they're like, well, we're sort of aware of this, and but it's like not very far. And then what happens is that people will get into this what they call double binds, where is to say that they have committed to some kind of work item that they need to get done, but they also must have committed to all the policies that when they sign up to work for you, right? So there's this document that they sign, they'll meet all the policies and guidelines, and somehow they realize that these are actually quite contradictory, and they'll sort of smash with each other. And you can't just like pick one because it will immediately invalidate the other, etc. And now what happens is two options. One of them is what's called road retreat within actually the safety literature. And I'm sure you have seen this when people say, well, I'm just like following policy. And basically they don't get any work done, right? Because they follow policy, and obviously the policy means that they cannot get the work done. And I have seen this in like machine learning, for example. They say, well, GDPR says I can't possibly use this data because we haven't actually asked the users for all the required consent. So I'm just gonna sit here and tumble my fingers, and this is gonna be great because you're asking me something that I cannot do, and therefore I'm just gonna be what's called in this work to roll. So then this is my role, and I'm just gonna work to roll. It's kind of an interesting. I'm sure you have seen this. And then the other one, and this is more often, at least in IT, this. Typically what happens, what's called covert work systems. And we have all been here. I have seen this many, many times. Basically what happens is work is done, so that the thing that they actually do on a daily basis is basically hidden from you. Because if you see it, you're going to throw your head into the nearest trash bin. So you're not going to be happy about it. So what happens is that they're going to start building systems to get the work done, right? But this is going to be insanely insecure, and they're going to hide it from you. And this is the difference between this kind of work as done and work as imagined. Because if you ask these IT security professionals, they'll tell you, oh, these are the policies and these are the things that everybody's doing. And then you go down into the trenches, and the people actually hitting the mine wall, and you're like, what is going on here? You're like, what? Like I didn't even the entire systems of work are there that you have no idea about, right? And this is not like, oh, it's an accident or something. This is a continuation of all the things that are here. It's not an accident that this happened. This is what's going to happen. Unless you do something about it, this is just the result of this centralized mode of control. All right, so what is you, the IT security professional, doing within this centralized mode of control? Well, of course, from safety. So the safety and security overlap so crazily. It's very interesting once you start reading this literature. By the way, there's lots of accidents that happen there, so I think we can all relate to that. So we support the task-based identification of hazards, right? We do risk analysis. We all do this, or threat modeling. You want to call it that. We facilitate the identification and assessment of system level hazards, right? So high-level risk assessment, like, hey, do we meet GDPR? And the other one, the task-based was like, hey, does this team, do things that would violate GDPR? We develop controls for tasks and processes, right? We all know this. We write the risk sheet. We set a list of requirements that they need to meet because clearly they missed the detective control and the preventative control and the reactive control. So we're just going to add all those controls in. We monitor proactively, blah, blah, blah. Obviously, we're going to have a look at detective measures and we're going to do incident management. Provide safety and incident compliance reporting, right? So and upper management and to the regulators. So you write these reports, the management is going to look at it, they're going to change priorities, etc. Support line management decision making, right? So we help them make the decisions to change the way that the way they do things, so that there's going to be lower risk. There's some part here, this promote authority to stop work. That's not something that we normally do. And we develop and promote safety culture and improvement programs. So we all know this, let's say, security champion programs, and Cisco calls this you get these belts. You get black belt if you're really good, and then white belt is where you start. Everybody has this. And then this is kind of this top-down thing, right? So we're gonna write some nice presentations, and we're gonna do some monthly meetings where all these security professionals are gonna tell all these stupid people how they should be doing their work, right? And this kind of very top down, we're gonna show you how security really is, right? So what can we do instead, right? That's the real question, because these are all kind of known. You have seen most of these probably. If you have spent maybe a few years in this space, you'll know that this has happened to you personally. And well, what can we do? Well, we can try to explore everyday work. We can try to sit there next to the engineers, the frontline workers, right? The people who are actually writing the code, of what the hell are they doing? Maybe you could just understand. Let's start there, right? Not a bad place to start, I'd say. You can try to support the practices that they actually are doing, right? Try to understand what they're doing and understand, the raw conflicts that they have to deal with every day, like smoothing and discounting and building these covert systems, and try to understand why are they doing this? Is there something that I can do to help them do this better in a way that is actually secure, right? Because the only other option is you try to beat them, and then there's somebody else will come because they'll leave, and they'll build their own covert systems, and now you're back to the same place, except it's a year later. Ooh, no, I'm still good. Okay, ooh, that went off. Right, you can try to facilitate information flow between the frontline workers and the upper management. Try to actually bridge the gap. right? And try to explain to upper management, like, okay, but like clearly you're asking them to do this and this at the same time, and they cannot possibly, like, there's no way for this to actually work. So we have to do something else. And it's not an easy thing neither to communicate that nor to find like ways to fix that, which is obviously the next thing, which is to generate like sort of operational scenarios that could actually work and try to find not a middle ground, but a way to make this all work in such that we meet the regulatory requirements that we have, and we all feel like this is something that the shareholders, let's say, would be comfortable with. And I think the hardest part within this, in my perspective at least, is facilitate sacrifice judgments. So when you're there, obviously some of the things will not be met. And now you'll have to figure out what are the things that you think would be best not to meet, because something is not going to get met. And so it's kind of difficult. I think it's people are not comfortable with saying that, oh yeah, we can't do that, but you can't do that. That's the point. That's the point. And now you need to figure out, which are the ones that we're gonna let go. And you have to have upper management sign off on that, basically, or like guide them towards a solution that actually makes sense. And now, okay, the last one is sort of in contrast to this kind of top-down, like, security champion stuff, where you sort of, instead of going there and telling these people how security is supposed to be done, you let them tell you how they think security is being done, right? And guide them through this process of trying to do it better. So, I mean, this is sort of just a question towards you about what do you want to be? Like, do you want to be this kind of setters of requirements, or do you want to be providers of capability? You're like, okay, this is actually by this Nancy Levinson. She does a really good job, actually. There was a workshop on this Stampa thing this summer. And basically the question is, are you writing uncontextualized policy documents that no one knows exist in the organization, and then holding employees accountable to those requirements set, with poor understanding of operational context? In other words, are you writing policy documents that you have no idea how they're going to get executed, and like how the work actually gets done, day to day? And I have seen documents that had no relation to how work was getting done, like zero. And the worst part about it is that the IT security professionals themselves discount things. They know, like, oh yeah, we know, but it's like, it's not such a big deal. So they start acting exactly like frontline personnel in a way, and they sort of understand that, by the way, there are these like covert systems that it's kind of insane almost. Right, so I think the real question is, like, maybe we should try to be providers of capability, like this positive slack, right? And improving this positive slack that is in the system, rather than trying to, like, set these requirements and basically try to plug every single hole you see. Okay, so this is, I think, by Decker. No, actually, this is hold on again. It's quite nice. So they have this idea of safety 1 and safety 2. So safety 1, I mean, at this point, I think you're all on the same, like, you understand at least where I'm coming from, and you should be quite clear, like, where this is going. So safety 1 is like, you learn from errors, right? You see the errors, and you only count the errors, not the successes. Never count the successes, only the errors. That's it's a very important aspect of this system. Safety is defined by absence. You look for holes, and you plug the holes, right? It's a reactive approach. Whenever there's a problem, you fix it. There's no problem, you don't fix it. You're understanding what goes wrong, right? All you're interested in is what went wrong. That's the question that every single incident report that you read answers. It's something to think about, actually. Accident causation models, right? So, I mean, this is maybe not that interesting for us, but it's usually what happens is that they look the accident, and there's a lot of literature in this, and it's very interesting, but I'm not going to waste your time too much. Basically, the idea is that you go forward only. And you say, okay, this is where they were, and this is where they went, and eventually went wrong. And you never understand, like, okay, but if they did something else, they might have just went wrong as well. This is a classical mistake people make in this kind of causation system. Anyway, and avoidance of errors, like you try to avoid all errors, because all error is bad, instead of like trying to learn from errors, right? And you reduce losses, right? That's the whole point. And then the safety 2 is this kind of, you learn from successes. You try to understand what went right, and what are the things that we can do better, even better, so that the things that went right will go even better, right? Safety defined by presence, the presence of positive capability, right? Presence of the things that are there to make sure that if things go wrong, we'll be able to recover. We'll be there to fix it. Proactive approach, right? Understanding of what goes right instead of what goes wrong, like instead of looking for holes. Repeating of what went right, and creating new processes that are based on the things that we have identified as success. Okay, so I don't know if I have too much time, maybe a little. That's good. Okay, well then we'll have a discussion. That's going to be fun. Yes, always fun. So, drift into failure. So this, we all know this. I think we have all heard about this. The Challenger accident is a very classical one on this one, where there was this team and they are always kind of wrong, but it's kind of good. We're gonna run with it. We're gonna launch this shuttle, and it went well. So okay, maybe it's fine. Then let's launch it again and again, and then you sort of the margin it just gets eroded and eroded and eroded. So your margin of safety gets eroded, and eventually things blow up into your face. Right? This is kind of we have heard about this, I think. And so within the IT security space, the way this works is that there's this system X, and it's been running for a long number of years, and therefore system X must be safe, right? It's been running for a long time, it's good. But notice that the risk gets evaluated by people. It's not, even if it's a system that eventually calculates the risk somehow, it's like some risk sheet or some automated system, is the people who actually enter the information into that system. And people are usually working in a group, and the group reinforces each other. So you can sort of get down into some mechanism of thought that just carries you. And more interestingly, the people who are decision makers are actually part of this group, or at least are strongly influenced by this group, right? And how is this group made up, actually? Because what happens is that in a large organization, people come and leave, and some people, when they built the system, they knew that they were the margin was tight, right? But the thing is that they kept on eroding it a little bit because they're like, oh, there seems to be more leeway here. And then what happens is that these people leave, and the newcomers, they come in, the new hires come in, and they're like, oh, this is the norm. This is the norm. We can try to erode. We can try to this might have too much margin of error. Let me, let's squeeze it a little bit. And so what happens is that as people come into the organization, they'll be indoctrinated basically into this kind of risk that you're sort of living with. We're sort of accepted this risk somehow. Right. And have you noticed that when you have a new hire and you tell them about the things that you're the risks that you're running with, they're really surprised. They're like, are you sure? And that's kind of this effect when they're like, oh, they haven't been indoctrinated into your view of the risk, right? Because what happens is that you have done all the discounting already. You have you have all these oh yeah, it's kind of bad, I know, but have you thought about X, Y, Z? So you yourself have done this discounting, and you sort of lived into this world, and you have this effectively group thing already going on within the IT security space. And I'm not talking about the other frontline personnel. In this sense, you are the frontline personnel. Right, so accepting risk. This is more like a bit of a side note, but in safety, it's an interesting thing about accepting risks, because people can die, and how can you accept that? I accept that you die. I can't possibly accept that, right? There's no way that I can accept you dying, right? But in IT security, somehow we sort of we forget about this, because have you thought about a risk to whom? Actually, do you have a column about the risk to whom in your risk sheets? Is it first-party victim, the employee whose computer got a malware and clearly this attackers saw everything they were doing? I mean, they might have been doing some personal things on their laptop, right? They might have been writing personal emails to their other colleagues and chatting and whatnot. They're a victim in this scenario, right? Have you thought about different? Okay, the second party victim is the customer, right? The second party is the person who sort of signed up to your company to do their things, but they clearly did not sign up for their data to be leaked. And then there's the third-party victim who had no idea, right? They're like let's say that the direct messages that people send on Twitter will now suddenly be available to everyone. And I might have talked about someone who never used Twitter, right? And now this person is a third-party victim who is victimized, but and who accepted the risk? Well, some manager accepted the risk, right? They clearly didn't accept the risk, right? So it's a kind of an interesting thought to think about. Of course, when somebody dies, it's a bit different because, an airplane fall on your house, then you're clearly didn't accept that risk, and some manager did, by the way. But in this case, it's not as obvious, but still there is risk to people that never accepted that risk, and somebody accepts that risk, even though I'm not sure they have the authority to do so. So it's something to think about as you work as IT security professionals, because you will also be part of this risk acceptance process, right? You will be there, and you will be part of the people who actually help that person accept that risk. Okay, so more like an ethical sort of question to think about. Okay, so I'm just going to talk quickly about this thing called high reliability organizations. This is kind of this used to be very trendy at one point, and now it's very trendy again. It's kind of trendy in healthcare, but it's been well known in oil and gas and mining and this kind of high-risk organizations like aerospace, space, etc. And so Wikipedia says, I'm going to read it because it's actually not that bad. So high reliability organization is an organization that succeeded in avoiding catastrophes in an environment where normal accidents can be expected due to risk factors and complexity. Right, so what do HROs do? And I think this is not, like now that you have had to listen to me for like 35 minutes, I think you probably are sort of familiar with some of the things that are going to be said here. So they're going to be preoccupation with failure, right? Not success, remember. So preoccupation with failure, process failures addressed immediately and completely. It's still interesting to think about some of these things that they do here. And they do manage to avoid failure quite often. There's something to be learned from HROs, I think. Reluctance to simplify. Complex problems get complex solutions. When was the last time you had like a really complex problem and somebody came up with a really simple solution and it did not work? It just did not work. Sensitivity to operations. So this is more closer to what this basically safety tool, this kind of, I would say, guided mode of security or safety, where every voice matters. So that is to say, you actually are interested in what the people are doing on the ground and try to understand what they're up to. Next one is commitment to resilience. So basically, commitment to resilience. So basically, recovery is swift. Point being that you try to have this kind of positive slack in your system so that you can recover from potentially dangerous situations quite quickly. And finally, deference to expertise. So instead of hierarchy, it's the experts who are actually, guiding this organization towards a more safe scenario. The HRO is actually kind of interesting, and there's quite a lot of literature in it. And I mean, it's part of Wikipedia, so it's like not as like at the edge of knowledge. It's kind of well known. You can read quite a lot about them. Okay, so this is by Decker's talk at the DevOps Summit a few years ago. Decker is one of these kind of well-known people within this space, Sidney Decker. I'll have a list of references. So he has this thing called safety currently and safety differently. He's kind of preoccupied with this idea of safety differently. And again, this is nothing new to you right now. So, in safety currently, there's people are the problem. You need to control them, right? We need to tell them what to do. And you have to count your successes by the absence of the negative, right? And you count all your successes by, all the holes that you didn't find. And safety differently is when the people are the solution. Like the person who was looking around and found this, and the attacker accidentally while sort of snooping around their own AWS account are actually the solution. Or the sysadmin team that recognized the gravity of the situation and immediately deleted the accounts, even before the SOC was like, woke up from their dream, basically, right? And you're supposed to be there to ask them what they need so that you can help them get the work done in a way that is secure or safe in the space. And you're supposed to count the positive capacities in the system, rather than like looking for the negative slack. You're looking for the positive slack in the system. I think I'm going to end here so you can actually have questions towards me. I want to talk a little bit about the references here. So there's this guy called Mario Platt who tries to bring a lot of these things together, I think, and he's been doing really interesting work, I find. You can find him everywhere. He's got a very nice blog as well. Sidney Decker, he's got a few books here. Drift into Failure is something that I think sounds good, but more interestingly, I would say the Field Guide to Understanding Human Error is much, much better, and it will make fun of all this crap about the down and in, and will tell you about how to do the up and out, how to look for distal causes, the things that actually really did go wrong in a way that you can try to fix so that the proximal cause will not even be kind of interesting. And then there are some others. I mean, there's Deanne Vaughan's The Challenger Launch Decision. So that's about this group thing that I mentioned. She's actually a sociologist. And more interestingly, actually, most of the people are not technical here, which is also, Mario Platt talks quite a lot about this, that you need to bring in a multidisciplinary team to do IT security. If all you have is IT security professionals with techies, basically, you might be able to do better if you try to bring in others. Because a lot of the things that I talked about actually are more on the social side of things rather than the technical side of things. I didn't talk about XSS. Actually, the XSS would be the proximal calls. You still need to understand that, right? You still need to understand how the damn thing went wrong. But the thing is that to fix it, you don't only need to know the technology. You actually need to go up higher and understand what were the influences that led to that thing going wrong. Right, so Diane Vaughan is a sociologist, and so is Rasmussen, and a bunch of others. Anyway, they're very kind of cool. It's been around since a while. This 1978 is one of the classics, the original sort of this man-made disasters, where it's like, hey, basically everybody at that point, everybody blamed the technology and the frontline worker, like, oh, they did the wrong thing, they pushed the wrong button. I mean, there's this very classical, I don't know if I have the picture somewhere, maybe I do have the picture. No, I don't have the picture, where there's like, they used to crash the planes from coming back from the US, from bombing campaigns in the Second World War. And it's like the button for taking the flaps down and putting the gear down were like the same freaking button next to each other. And then like, and they blame the pilots like nonstop. And they're like, dude, like and they've been like flying for 16 hours, you know? I mean, of course they're gonna push the wrong button. And they just died. I mean, a lot of people died. Anyway, so this is the end. I hope you have some questions.